Okay, so I know I'm gonna probably get a lot of hate for this video, but there's not much information out there about, oh my goodness. Do you guys hear that? There's gotta be like 100 crows over there. Hey guys, I'm trying to film a video. Well, just ignore the crows in the background. But okay, so there's not a whole lot of information out there about what miticides or chemical treatments do to our bees when compared to how much literature is out there about mite control. So I figured I'd be the one to do this video because it's some pretty crazy stuff. Okay, so as a beekeeper, I'm sure you've probably heard of colony collapse disorder before. What it pretty much is it's when our colonies completely collapse. The bees either abscond or it shrinks and shrinks and shrinks to a very small number of bees, and the queen, usually sometime during like the summer, late summer, and into the fall. In the most recent years, it has started to go down a little bit, but we are still having crazy high numbers, up to around 50% of managed colonies collapse every single year, which is absolutely insane. That number is, in my opinion, just completely outrageous. So some of the reasons why we're having this issue, there's so many different factors that kind of go into it. But the most common one that everyone talks about is they blame it on varroa, pesticide use, stress to the colonies when related to moving them in like migratory beekeeping and whatnot, moving them from field to field and whatnot. Also new viruses and gut parasites that have been popping up in our honeybees. And then unfortunately, poor nutrition due to less forage areas, as we've been kind of tearing down their habitats and their forage ground to put up buildings and build other things, or put lawns and grass and stuff like that. So colony collapse disorder is definitely sort of an issue in beekeeping. But one of the other things that I kind of realized when I was reading all this research is one of the factors we're probably having it is also because of our use of miticides or chemical treatments. So like I said, I'm going to get so much hate for this video, but I just want to share with you the information that I'm learning so that you can make an educated opinion about how you want to take care and manage your bees. So yeah, that's the only reason I'm talking about this. So let's go ahead and get straight into this. I took notes on all of this, and the first one we're going to talk about is Amitraz or Apivar. As you guys know, my absolutely favorite treatment. Not really. But it seems to be the most common, as it is something that it has been synthetically made to treat against varroa, but as I was reading, I was realizing there are a lot of negative effects that it has on honeybees itself. So Apivar doesn't persist in the hive environment, but its metabolites do. So I'm not going to say the long technical term because it's kind of hard to pronounce, but I'm just going to call it DPMF. That's the abbreviation for it. But what DPMF does is it accumulates in the wax and the pollen and in the bees itself. So Amitraz acts on different receptors in a bee's brain, particularly the octopaminergic. I'll put it up on the screen so you guys can see how it's spelled. But it works off of these receptors, and what it does is it's able to influence honeybee behavior, learning, and memory function, along with other physiological processes. So remember, we're applying these chemicals to our bees to treat a sort of, I wouldn't really call it a bug or an insect, because it's not a bug or an insect. It's definitely, they're very parasitic. I think they're called like arachnoids or something like that. But to treat something that is kind of similar to an insect living on an insect. So you can kind of figure there's going to be negative consequences to that, as they are pretty similar in the way that their whole bodily processes work and whatnot. I say similar, not exactly the same, just similar though. But okay, so I'm just gonna read off my notes. Amitraz has been shown to stimulate receptors in the brain that play a role in modulating honeybee hygienic behavior. So it has a way of affecting the way they clean each other and they groom each other. This could definitely have negative consequences, especially since we are trying to breed bees that have hygienic traits so that they can take out brood and get rid of mites and whatnot on their own and other diseases that infect the brood. But also, this was a really crazy thing that I saw. So it acts on their cardiovascular system, and it acts as a cardioaccelerant. So it speeds up their heart. And acute exposure to Amitraz has been shown to cause all death in midgut of honeybee larvae. So it's also impacting their gut health. So bees, they actually have a microbiome the same way that we do. And it helps influence their immune system and helps them fight off different things. And it's what helps them make honey. It's really important for the overall health of the bee. And I think I remember reading somewhere too that it does impact neurotransmitters in their brain, because they also have neurotransmitters just like us humans do, and that kind of that's what affects how they act, what they do, their like pretty much their whole behavior and makeup is all affected by this. So when you put Apivar in your hive, you're affecting their gut and you're speeding up their heart, which is definitely going to have negative consequences. But also in the study, it showed when challenged with a viral infection, there was a very, very high bee mortality rate when treated with Amitraz versus the control. There was a 75 to 83% mortality rate in those that were treated with Amitraz when exposed to a virus within a day. Then after 3 days, there was a 100% mortality rate versus only 10% for the infected control that was not ever treated with Amitraz. So one of the things that it was talking about is that anything that affects the cardiovascular system of the bee also affects their immune system. So it's speeding up their heart rate, it's lowering their immune system. So as soon as a virus gets brought into that colony, it completely eradicates the colony and causes it to collapse. Versus if you had never treated to begin with, then they would be able to fight off that virus. But then again, then you have high mite levels. So yeah. There's one more thing that I want to mention that I forgot to add, and that is that, so when you affect the heart, you're also going to affect the circulatory system, and a bee's circulatory system plays a role in thermoregulation, ventilation, and maintenance of homeostasis. So you're also going to be affecting the way they're able to keep warm versus freezing to death, so this could really impact their winter survival rate. But also, one of the things to kind of mention too is that Amitraz, the active ingredient that's in Apivar, has also been showing to cause resistance in mites, and that's because it leaves residues in the wax, in the pollen, in the honey. It leaves residues in all over the colony, so it's exposing those mites to this active ingredient constantly so that they can pretty much mutate and find a resistance to it. But not only that, it's also exposing the bees and the actual larva, the brood, to this chemical. And in the study, it was talking about how they were seeing that there was a very high brood loss because there was these leftover residues left in the cocoon of the cells that the brood was reproducing in. So yeah, overall, not really good. So okay, I'm going to put up a chart that I ran across that talks about all of the other different forms of treatment. And this chart absolutely blew my mind. It's absolutely amazing. So make sure you take a screenshot of it if you want to kind of like look it over and see exactly what each treatment does and how it affects the bee. So let's start with the first one and start going down the list. Okay, so we already talked about Amitraz, and as you can see, there are many other effects that it has on the bees that are pretty negative, unfortunately. But okay, so scroll on down. Flumethrin, we don't really use that much today, but it's commonly known as Apistan. I've never used it personally. Like I said, I haven't really heard of people using it. It's not really one of the common ones. So let's just keep going down to Formic Acid. Okay, so this is a really popular one. This is the one that I usually end up using. But okay, so formic acid, it lowers the pH of honey stores through the following season. It interrupts brood rearing. This is something that I always saw whenever I used formic acid, that it would pretty much almost eliminate my brood. It would definitely cut it in at least half so that I'd barely have any left. And I did see a lot of bee mortality. Usually my populations went down quite a bit whenever I used formic, so I had to use it sparingly and kind of work with the different flows in the season of when I would use it. But as you can see, they also talk about this, and it also lowers adult drone survival and delays drone production. Drone eggs are removed from combs. So yeah, not good. It lowers larval feeding. It messes with their hydrogen ions as well. Increases heat shock proteins, lowers the area of sealed brood, as it does kill some of the brood, and they will end up uncapping it and removing it since that brood is dead. And formic also does cause cell death in their gut, so it also affects their microbiome, unfortunately. Now, this study is showing the formic's effect on varroa mites, queen mortality rate, and worker bee mortality rate. And what they ended up finding is that, so there are two ways of using formic. There's a low dose for a long amount of time or a high dose for a short amount of time. And what they saw is that in order for formic to be effective at killing the most amount of mites, you had to do a high dose. Otherwise, if you did the low dose, it only killed around 60% of the mites in that colony versus killing 90%. But then there was another drawback with that. In using the high dose, you also had a high worker bee mortality rate versus the low dose didn't really kill off that many worker bees. So I guess take that with what you will, whether you want to kill mites or you want to kill bees. I mean, you obviously want to kill the mites since that's the whole reason you're applying the treatment to begin with, but this was just some good information to see. Okay, so let's move on to everybody's favorite, oxalic acid. It's supposed to be more of a softer treatment for the bees. So that's why everybody loves it so much, and so far that's the one that I've seen to be the softest on the bees in terms of it doesn't kill a whole lot of bees and it doesn't completely ruin the brood. But according to the study, they saw that actually it does increase cap brood removal, it does increase bee mortality rate, and it can penetrate keratin, which is a protective layer on the bees, and pretty much get to their organs, which is also not good. So it decreases colony strength, it increases colony mortality, it lowers the pH of honey stores, which is very important for the bees for it to be in a certain pH. Otherwise, it's going to impact their gut health as well and their overall health and immune system. So because of this, it can cause permanent damage to the bees' digestive system and organs. So of course, that's not good. But moving on now to Thymol, which is commonly known as ApiLife Var or Apiguard. So this also has a negative effect on the bees. It lowers the amount of brood, it slows down colony development, lowers food intake, it lowers the sperm numbers in drones, and it increases larval and pupal mortality. It messes with a lot of the different genes that are in bees that are responsible for different processes, so it can lower their immune system and kind of make everything go all wonky. So all of this tells me is, yes, we are killing mites, but we're also really kind of killing bees at the same time. So yeah, we don't have mites on our bees and our bees aren't dying of mites, but now they're dying of something else, or they're just barely even scraping by to begin with. So it's kind of like, okay, you don't want the bees to die of mites, but then also all these chemical treatments are not really working. So what are we going to do to save our bees and kind of prevent these high numbers in mortality when it comes to colony collapse disorder every single year? And one of the things I'm also kind of realizing is that miticides make the bees so weak that you pretty much have to kind of pick between either constantly treating and staying on top of the mite so that there's pretty much no mites in that colony ever, because the moment a mite gets brought into that colony after you treat it, it's already super weak because of the treatment and what it did to the bee and its physiology, that as soon as a mite comes into that colony, they have no way of having any sort of strength against those mites, and it just demolishes the colony. So either you have to treat constantly or you don't treat at all. but it's when you do it in the middle where you only treat maybe like here and there that we're really seeing negative impacts on our bees, because they're just not strong enough and their immune system's pretty much shot after one treatment to be able to fight anything off. So yeah, you cut the mites down, but now your bees are sick and vulnerable, and like I keep saying, the colony ends up collapsing. So what are some of the solutions that we can start using to help our bees? The main two things that I've really thought of so far, and please chime in if you have any ideas as well, because I'm realizing that to keep going in the direction we're going, I mean, a lot of us have already said it, that it's not really going to go well for the bees. And I'm going to get a lot of hate for this, but I really feel like in the future, we're going to reach a point where we're going to have to change the way we manage our colonies if we want to be successful. So the two main ways that I've really thought of to be able to mitigate this problem is, one, to always try to breed off of hygienic bees that are able to uncap brood and pull out sick brood and remove it, because that really helps knock the mite load down and knock any other disease down that could be in that colony, instead of letting it just stay there and keep reproducing and multiplying and, you know. And then the other way that I'm probably going to implement this year is using simulated brood breaks in July. So I have this book by Mel. I've talked about it in a couple different videos because the book is absolutely great. But in that book, he has a chart that shows how the bees, how they grow over the course of the year, along with the mites. And right around July is when the mites really start to kind of go up, and then they really start skyrocketing just as the bees are also going down. That I'm trying to draw a diagram in the air for you, but that is not working whatsoever. But okay, so yeah, the mites, they really start to go up. And what he talks about is right as soon as the mites start to go up, that's when you hit a brood break. Because then right when those mites are like, oh, hey, we're going to do this, there's no more brood for those mites to go into the cell and reproduce. So they pretty much end up self-destructing, and you get rid of all the mites in that colony. It's pretty effective. So that is something I'm going to kind of utilize this year, is a brood break in July, along with requeening the colonies, because there's a lot of talk about post-solstice queens and how effective they are. I had a couple last year, and I absolutely loved how they performed. They are literal brood factories, and they really seem to create strong colonies going into the winter. So that's definitely something I'm going to utilize in my program, is always using summer solstice queens to requeen during my brood break. So I really think that selecting our best colonies and breeding off of those is something that's going to be very, very popular in our future for the course of beekeeping in order to be successful, especially since, like I'm saying, what we're seeing is these hygienic bees are a real need in beekeeping, in order to kind of like fight against the mites without weakening our bees with miticides and all of that. So I hope you don't hate me too much after this video, kind of removing the veil that has been over miticides and how they affect honeybees. Like I said, the only reason I'm sharing this with you is because I'm just trying to share all the research, all the facts and information that are out there so that you can make an educated opinion yourself on how you want to manage your own bees. I'm not trying to tell you what to do, just giving you information, that's all. But anyways, I hope you guys are doing well. I hope you're staying warm and enjoying bee winter. And as always, I will see you in the next one.